All right, so tonight for hazardous material operations, we're going to talk about incident-specific strategies, along with terrorism, terrorists, and criminal incidents. Get those combined. So when in hazardous materials incidents response, we are always going back to the basics, where we need to make sure the basics are taken care of before we move on to any advanced mitigation actions, including defensive actions for operations level mitigation. So we're going to review that again. So for any hazardous material incident, regardless of size or what the material is, we have to consider some things, including wind direction and terrain. We want to make sure we're uphill and upwind. We're going to implement the incident command system. That way we can get things organized. The reason that's so significant is occasionally hazardous material incidents will grow to the size where they're multi-day, multi-jurisdictional. And if we can start the basics of the incident command system early, then it's easier to transition into those multi-day incidents where we might have a incident management team come in. Now, for the smaller everyday, day-to-day incidents that most firefighters deal with, we just need the basics of the incident command system implemented, the incident commander and the safety officer. Utilize the ERG. It's a great resource to help you get started where you might feel like you have no idea where to start. It's just nice and easy, 2 pages, tells you exactly how to get things started. We're going to isolate and evacuate the area. We're going to call for additional assistance. If we don't feel like we can handle this at our training, with the number of people we have, with the equipment we have, we're going to call for additional assistance. We're going to avoid physical contact with the material. With operations level response, we should not be coming in physical contact with the hazardous material. We're going to wear the appropriate PPE. In order to know what that is, we have to know what the material is, or specifically, we have to know what its hazards are. And for all incidents, we're going to eliminate ignition sources. So vehicles, electricity, movement of flowing things, no smoking, things like that. For all incidents, operations actions that we can take, we're going to protect exposures when fire is involved. Our primary responsibility for operations is, on top of our awareness responsibilities, is trying to keep this incident from getting bigger. So we protect exposures when fire is involved. That's part of that. We're trying to keep other things from catching on fire. We're going to wear full PPE, SCBA, or other respiratory protection when operating in or near the danger zone or the hot zone. And we're going to conduct rescues when it's safe and appropriate to do so. That's in all incidents. So now we're going to get into specific incidents, and we're going to do it by DOT class. So class 1 are explosives. The type of containers that you'll deal with explosives are either paper or plastic cartridges, plastic tubes, fiberboard cartons, metal cans, multi-walled paper bags, and special cargo trucks. They'll have the orange class 1 DOT placard. Okay, so what do we do if there is no fire involved? And remember, a hazardous material incident is when the material is not where it's supposed to be. If it's in its container and it's being transported and it's in its transportation vehicle, there's no incident. It's when it gets out of its container or out of its vehicle, that's when we have an incident. So no fire involved, we're going to get people out of the line of sight of the scene. Okay, we're going to evacuate. We're going to review the vehicle shipping papers, identify the material. We're going to visually inspect the load from a safe distance. So how do you inspect the load from a safe distance and review the vehicle shipping papers? You're hopefully going to talk to the driver, and they're going to hopefully bring them with them. If you don't have them, don't go get them. If you're going to visually inspect the load from a safe distance, how do you do that? You can use binoculars. Consult the appropriate technical specialists. Where are you going to find those? Hopefully on those shipping papers. You can also call explosive experts, specifically federal agencies such as either the FBI would come out of Springfield or the ATF. I don't know where their closest office is. We're going to ground any equipment that we use when handling the product if we are told to handle the product. And we're going to protect the cargo from contamination and shock. That means if there's a multi-material incident, we don't want any other hazardous materials, even water, getting in, or maybe not water, other hazardous materials getting in contact with the explosives. And we're going to have the responsible party, which is usually the transportation company, make the necessary contacts for transfer or disposal. Here's things we're not going to do. We're not going to touch them or their containers. If they're just sitting there, leave them alone. Also, if there's anything indicating electronic detonators in this transportation vehicle, we are not going to operate any radio transmitters within 330 feet. So that is the entire football field. So if fire is involved with explosives, again, isolate and evacuate according to the ERG. Do not fight the fire when the fire reaches the explosives. We're going to withdraw to a safe distance according to the ERG and let the fire burn. So this is one of our defensive control options of controlled fire. Not really controlled burn, but we're gonna let it burn. Do not move, touch, or shock explosives that have been exposed to heat. So once the fire stops, or even if it goes out on its own, we are not going to approach it. Let somebody else deal with that. We're just trying to keep it. There's nothing we can do to change what's happening. We're going to keep it from getting worse and getting anybody injured. All right, so in the event that the explosives are not on fire themselves, but are threatened by fire, again, isolate and evacuate. You're going to hear that over and over again. Extinguish the fire before it progresses and confine the runoff water, or try to. Consider it. So the makers of explosives and the DOT recommend that first responders do not make an attack on fires involved explosives. Instead, they should withdraw and let the fire burn. Again, if we have explosives and fire, that's it. We're done. Move back. If we have to explain to the media that that's what we're doing, why we're not putting it out, say the safest option is to withdraw, non-intervention. There's no reason for us to handle any suspected explosive device. If it's sitting there, let it sit there, wait for somebody who is an expert to deal with it. DOT Class 2, gases. So the containers we're going to see these in are pressure cylinders, pressure tanks, and pipelines. So if we have a non-flammable gas that is nothing, there's no fire involved at all, isolate and evacuate, stay out of low areas, allow that to evaporate as appropriate. If it's coming out of its container for hazmat operations, we're going to just allow it to evaporate as appropriate. Now, if we are needing to protect an exposure, then we can use a water spray to reduce vapors or divert the vapor cloud. We also need to consider the runoff from that. We're going to prevent our runoff water or any liquids from entering waterways, sewers, basements, or confined areas. If it's enclosed, we're going to ventilate the area and hopefully stop the leak with a remote valve without coming in contact with it. Continuing on with non-flammable, no fire. Do not direct water at the source of the leak or any safety devices such as pressure relief valves because icing may occur. So when a compressed gas expands, it absorbs heat to do that because it's changing a phase from a liquid to a gas, which means it absorbs heat, which means it cools its surrounding environment. So when that happens and you add water, you can have freezing. Why is that important? Because if we form a ice block at the leak and the leak diminishes or, excuse me, or even stops, and we stop applying water to it, eventually that ice will melt and the leak will continue, and it may be unnoticed. We don't want any surprises, so don't direct any water spray at the point of the release because of that. If it's a non-flammable gas and there is fire involved, again, use the ERG. If we can, move any undamaged containers from the fire area, do it safely, so we don't want them to be exposed. Stay away from the tanks engulfed in fire. Use an extinguishing agent suitable for the type of the surrounding fire. So we have to consider our fuel. We're going to fight the fire from maximum distance or use unattended hose streams, which means usually things like a crossfire or a blitz fire, a ground monitor of some sort. We're going to cool containers with flooding quantities of water, which means we're going to see the water running off, means it's not evaporating. We're going to withdraw immediately in case of a rising sound from venting safety devices or if the tanks become discolored from the heat. We talked about unattended hose streams. If that's not possible, we're going to withdraw, let the fire burn, and then protect exposures. Again, don't direct your water at the leak or safety devices. If it's an oxidizing gas, again, isolate and evacuate. We're going to keep combustible materials away. Now, oxidizing gases promote oxidation, which fire is a form of oxidation. So we're going to keep combustible materials away. We're going to allow it to evaporate. We're going to use our water spray to divert or reduce vapors, control our water runoff, and hopefully close it with a remote valve. This depends on the situation. Oxidizing agents with fire, as always, isolate and evacuate. We're going to move undamaged containers, stay away from the tank, use a suitable extinguishing agent for the fuel that's on fire, maximum distance, cool containers, withdraw, unattended hose lines, protect exposures, and we talked about not directing water at the source. All right, moving on to flammable gas, no fire, isolate and evacuate, eliminate all ignition sources, stay out of low areas. We're going to use a water spray to reduce vapors or divert vapor cloud, contain that water runoff. We're going to use a remote valve to stop the leak. If it's safe, ground all equipment. Use non-sparking tools. If it is involved in a fire, we're going to stay away from it. Don't extinguish a leaking gas fire unless the leak can be stopped. Remember, when we have a pressurized gas, combustible gas that's on fire, we want to stop the fuel before we extinguish the fire. Cool containers, again, flooding quantities with the water running, dripping off the container. We're going to withdraw if we hear the venting increase in volume or pitch. Using maximum distance, unattended hoses, protect exposures. We'll hear a lot of this repeated over and over again for these gases. Keep the water spray away from the leak. All right, things are going to change up a little bit with class 3 flammable liquids. Container types you're going to see these materials in are metal cans, pails, drums, tanks, tankers, pipelines. So we have a flammable liquid that's spilled, but no fire. We're going to use that ERG, isolate and evacuate, eliminate all ignition sources. We're going to turn off power. We're going to keep vehicles away. We're going to stop any leaks from the normal piping by closing a remote valve. Use vapor suppressing foam to reduce vapors if we need to. How do we know that? We're going to monitor. If the amount of vapors is less than the lower explosive limit, then we don't want to put vapor suppressing foam down because that just makes a bigger problem. We're going to ground all equipment and use explosion-proof fans if we need to. We're going to dike waterways, sewers, basements, or confined areas. We're going to divert leaking liquids away from the incident scene and exposures. And we're going to dike and dam far ahead of the liquid for retention and later disposal. If it's spilled and there's fire involved, use that ERG. We're going to stop the leak with a remote valve. We're going to lay initial hose lines. We're going to establish a continuous water supply, cool containers, use a water spray fog or appropriate foam solutions. However, be aware that water spray alone may be ineffective for fighting flammable liquid fires. It's not what it's designed to do. If there's a tank with a safety device and hear a rising sound, we're going to withdraw. We're going to fight from maximum distance or use unattended hose lines, protect exposures, control flowing liquid. Avoid the use of straight streams. The reason we do that is we don't want to spray the flammable liquid and atomize it and spread the fire. So no straight streams, only fog streams. Class 4 flammable solids. You're going to see these in tubes, pails, steel drums, fiberboard drums, cardboard boxes, and bags. If it's spilled, nothing's on fire, get that ERG. Again, eliminate ignition sources. And keep it from extending from the leak. If it's on fire, ERG, stay away from it, cool the containers, withdraw. Use the appropriate extinguishing agents for small quantities of burning flammable solids. If you have a large quantity of flammable solids, we're going to allow that to burn because water may not be the best choice. We may not have enough of it. Could make it worse. If we do choose to use water, maximum distance again, or unattended hose lines, we're going to protect those exposures, dike, dam, divert, and retain any runoff water. If it's a class 4 spontaneously combustible, first step, ERG, eliminate ignition sources, keep it from going where we don't want it. If it does catch on fire, ERG, stay away from it, withdraw, protect exposures. You're not going to be able to put this fire out. You're just going to have to wait for it to burn. Class 4 dangerous when wet materials. So it's spilled and no fire. ERG, ignition sources, keep the combustibles away. Prevent contact with water or wet materials. Use the ERG guidelines. They'll tell you what to use. You can cover small powder spills with a plastic sheet or tarp to minimize the spread and keep the powder dry. Hopefully it's not raining. If it does happen to get on fire, use the ERG, stay away from it, just withdraw and let the fire consume the fuel and protect exposures. Don't use water or foam with something that's labeled dangerous when wet. If it says dangerous when wet, don't get it wet. Do not let water get inside the containers when attempting to cool. That makes things even worse. Class 5 oxidizers. Containers you're going to see these materials are plastic lined, multi-ply paper, metal tins, fiberboard, plastic, metal drums, portable, stationary, and applicator tanks. If it's not on fire, again, ERG, eliminate ignition sources, keep combustibles away, withdraw if in doubt, dam, dike, divert, or retain from a distance as appropriate. If fire is involved, ERG, stay away, withdraw, flood the fire area with water from a safe distance if you decide to fight the fire. We're going to cool tanks or containers, withdraw, and protect exposures. Organic peroxides with no fire, ERG, eliminate ignition sources, keep combustibles away, and withdraw if necessary. If they're on fire, pretty easy. ERG, withdraw, let the fire consume the fuel, protect exposures. Nothing you can do about it. Moving on to class 6, poisons or toxins. These will be found in intermodal portable tanks, tank trucks, railroad tank cars, barges, marine tankers, or even small vials packed in strong containers, such as infectious substances. If these spill with no fire, start out with the ERG. If you can, close a remote valve to stop the leak. Cover the spills of solids with tarps or plastic sheeting to prevent the spreading. Dike, dam, divert, and retain as appropriate to keep them out of water and other confined areas. Avoid getting water inside the containers. If fire is involved, start with the ERG, stay away, withdraw. Follow the ERG or expert guidance if you decide to fight the fire, and cool tanks and containers. Dike, dam, divert your runoff water. Withdraw if necessary, protect exposures. Infectious substances. Start with the ERG, cover with damp towels or rags, and keep them wet with liquid bleach or other disinfectant. That's a little bit different than what we've talked about before. So infectious substances, we're not going to try to really save anything. So cover it with damp towels or rags, keep them wet, don't get in it. If fire is involved, start with the ERG, allow the fire to burn and destroy the infectious substance, and protect exposures. Class 7, radioactive materials. Remember the container types? Type A containers are going to be cardboard boxes, wooden crates, cylinders, metal drums. That's the lower radioactive energy materials. Type B is the higher radioactive energy materials, steel reinforced concrete casks, lead pipes, and heavy gauge metal drums. If there's no fire involved, get that ERG out and use it to determine time, distance, and shielding for protection. If fire is involved, we're going to isolate and evacuate using that ERG. We're going to extinguish the fire according to normal procedures unless the material is corrosive or water sensitive, in which case do not use water or foam. We're going to control our runoff water through dike, dam, divert, or retain. We're going to protect exposures. Pretty easy. Just stay away from it. Let somebody else clean it up. Class 8, corrosives. These are going to be found in glass or plastic bottles. Also carboys, either glass or plastic. Plastic drums, fiberboard drums, and multi-layered paper bags. No fire with a corrosive spill. Start with the ERG. Close that remote valve. Cover the spills of solids with tarps or plastic sheeting. Use foam to reduce vapors when appropriate. Use fog streams to disperse or redirect vapors when appropriate. Control and confine runoff water because it's going to become corrosive itself. Dike, dam, divert, and retain. And prevent contact with organic materials or other corrosives. Remember, if a base interacts with an acid, chemical reaction is going to happen. Avoid water getting inside the containers or contacting spilled material. So, especially with acids, if it's a highly concentrated acid, adding relatively small amounts of water can cause a reaction. Usually you want to add acid to water, not water to acid. So to avoid that, we don't want to get water inside any containers. Corrosives that are involved in fire, start with the ERG, stay away from it, withdraw and let the fire burn. Many times water can make the situation worse. If you do decide to fight the fire, use the ERG or some expert guidance. We talked about where we can get expert guidance, either from Chemtrek or from the manufacturer. We're going to cool tanks or containers with flooding water, but not letting water getting inside the containers. We're going to control our runoff water. If we have rising sounds from venting safety devices or discoloration of the tank, we're going to withdraw immediately and protect exposures. And our last DOT class, miscellaneous materials, it's pretty generic. Container types are various and be made out of anything. Actions that we're going to take, we're just going to use the ERG to tell us how to isolate and evacuate the area. All right, so that's the incident-specific strategies. Pretty repetitive for hazmat operations. And now we will move on to terrorism and criminal activities. So unfortunately, terrorists and criminals also have interest in hazardous materials. And so we have to be able to deal with that as well. So what is terrorism? It's a three-part definition for terrorism to be identified. All three of these parts need to be in place. Number one, the unlawful use of force against persons or property. Number two, the actions are intended to intimidate or coerce a government, the civilian population, or any segment thereof. And number three, their actions are in the furtherance of political or social objectives. You have to have all three in order to have something defined as terrorism. The goals of terrorism are recognition, coercion, intimidation, and provocation. They want to be known. They want to get you to do something, coercion, and they want you to feel less powerful than them, and they want to provoke you to take action, do something. Not many times, but something we have to talk about are weapons of mass destruction. What is that? Any weapon or device that is intended or has the capability to cause death or serious bodily injury to a significant number of people through the release, dissemination, or impact of one of these three things or a combination: toxic or poisonous chemicals or their precursors. So precursors, some are the chemicals that are used to make a final product. many times the precursors are pretty hazardous themselves. Could also be a disease organism, and also could have radiation or radioactivity. A terrorism event is different from the routine. How is it different from our routine hazardous material incidents? There's usually a large number of casualties. It's usually very exotic materials, things that first responders have little experience dealing with. Sometimes there's secondary devices or events that are used that are intended to incapacitate or delay emergency responders. So you'll have an initial event that gets you called, and then as you're responding, there's either a secondary device or a secondary event that is intended to harm you. Could also involve armed resistance, the use of personal weapons such as guns, booby traps, and secondary contamination from handling patients. Most of our hazardous material incidents that we deal with most often do not have contaminated victims. But that's the point of a terrorist act. So that's where they would come from. Potential targets for terrorism include public assembly occupancies and locations. So think about movie theaters, concert venues, sports stadiums and arenas, things like that. Public or government buildings, many times we talked about either a political or social motivation. Sometimes terrorists are upset with the government, so that's who they attack. Utilities, specifically water, and I misspelled utilities. Especially water systems. Just recently, we had a couple incidents in the country a couple of months ago, in the last couple of months, where former employees still had the ability to make changes to computerized water treatment systems. Mass transit systems, that's happened a couple of times in the past decade or so. Places with high economic impact, so that could be, so for example, I think SIUE is the county's largest employer. So if you took that out, then a large number of employees may not have income. Telecommunication facilities, places with historical or symbolic significance, military installations, airports, or industrial facilities. Industrial facilities are a target that draw criminals and terrorists because the hazardous materials are already there. They don't have to manufacture them. So clues to consider. These are the red flags that when we respond to an incident may direct us to thinking this may be a criminal or terroristic event. A report of 2 or more medical emergencies in public locations, such as a shopping mall, transportation hub, mass transit system, office building, assembly occupancy, or other public building, or an unusually large number of people with similar signs and symptoms going to physicians' offices or hospital emergency rooms. That's how sometimes these get discovered. You have a large number of people going to the hospital, they were at the same place and with the same complaint. Also, a reported explosion at a movie theater, department store, office building, government building, or a location with historical or symbolic significance. Of course, there's an acronym. Categories of terroristic attacks involving hazardous materials. Because they are not, we use the acronym Be Nice. And those stand for biological, nuclear, incendiary, chemical, and explosive. Be nice. So what are biological weapons used by terrorists? They can be viral agents, bacterial agents, or biological toxins. Indicators of a biological attack are numerous sick or dead animals, fish or birds, unscheduled spraying or abandoned spray devices. So if somebody is seen spraying an area when they normally wouldn't be, or if somebody has just set a spray device or left it and walked away. Vapor clouds or mists that are unusual for the area or for the time of day. The absence of crops, wildlife, or insects that are common for the area, the time of day, or the time of year. Any out of place or unattended packages, boxes, or vehicles, packages that are leaking, materials or equipment that are unusual for the area, or even small explosions that disperse liquid, mists, or gases. Now, usually any one of these is not a red flag, but the more you get, the more likely it's a terroristic event. Unusual odors or tastes, multiple casualties without obvious signs of trauma, multiple victims who are exhibiting similar symptoms, or large numbers of persons seeking medical attention with similar symptoms that are not characteristic of the season. So if somebody's getting if a whole bunch of people are getting the flu that in the middle of summer, that's something to think about. Or it could be a pandemic. All right, the type A agents, biological agents, are easily disseminated or transmitted person to person. They cause a high mortality and subsequently have a major public health impact. They might cause public panic and social disruption, require special action for public health preparedness. Some examples of a type A agent would be smallpox, which has been eradicated in the wild. So if it does show up, it has gotten out of the labs. Anthrax, plague, and botulism are type A agents. Following that are type B agents. These are moderately easy to disseminate. They cause moderate morbidity and low mortality, which means we have less people, less serious illness, and a lesser number of people dying. They require specific enhancements of the center's disease control and prevention's diagnostic capacity and enhanced disease surveillance. Some examples are brucellosis and glanders. These are bacteria that can be made into weapons. They make you sick. Type C agents are emerging pathogens that could be engineered for mass dissemination in the future because of a couple of reasons: their availability, their ease of production and dissemination, potential for high morbidity and mortality and major health impact. Some examples are the Nipah virus, hantaviruses, and tick-borne hemorrhagic fever viruses. With a biological incident, many people are potentially at risk, including traditional first responders who transport ill patients to medical facilities, the healthcare workers who care for patients in hospitals, residential facilities, or outpatient settings at home or elsewhere, laboratory personnel handling clinical specimens, and health department staff who visit patients in or out of healthcare facilities while conducting outbreak assessment or control measures. So how can we protect ourselves since we're what are called frontline workers? We're going to run the ambulance ventilation systems on its highest settings using outside air circulation in order to maximize, so it should be maximize air changes in the vehicle. Not minimize, we're going to maximize air changes. For diseases that are transmitted by respiratory transmission, the patient should wear a surgical mask, a disposable respirator, or if needed for respiratory support, an oxygen mask that does not exhaust the ambient air. Responders transporting patients with different diseases may require different levels of worker respiratory protection. Now we're moving on to the N part of Be Nice, nuclear or radiological. 3 scenarios are most likely. Scenario number 1 is a detonation of a conventional explosive device that incorporates nuclear material. It's commonly known as a dirty bomb. So you'd have a normal explosive, so it'd be TNT or dynamite or something like that, that has nuclear material in it, and it just spreads that nuclear material around as dust or particles. Option number 2, scenario number 2, is an attack on a source of nuclear material, such as detonating a truck bomb in the vicinity of a nuclear power plant or radiological cargo in transport. So we're not going to get our hands on, the bad guys aren't getting a hand on any nuclear materials, but they explode something near nuclear material, and that causes it to release. And scenario number 3, detonation or threatening to detonate an actual nuclear bomb. That is the most difficult to do, and hopefully the least likely, and also potentially the worst option or worst scenario. Types of bombs, again, a dirty bomb, which we already talked about, an actual atomic or nuclear device, an improvised nuclear device, a suitcase bomb, or a nuclear power plant sabotage or attack. What are we going to do about it? We're going to use radiation and contamination survey instruments to determine radiation levels. We're going to use our radiation detector monitors. We're going to utilize the principles of time, distance, and shielding to protect against radiation exposure. We're going to stay away from ground zero, entering the surrounding area, only to save lives and only if wearing appropriate PPE. Remember, the only PPE we have, the only thing that PPE we have will protect us from is definitely alpha and possibly beta. We don't have any PPE that will protect us from gamma radiation. And we're going to establish controlled zones just like any other incident. Isolate and evacuate. Or shelter in place as appropriate. We're going to wear respiratory protection. Remember, the alpha and beta particles radiation is worse when it gets inside our body. The easiest way to do that is inhalation of the radioactive dust. Standard firefighting gear or easily removed outer clothing is sufficient to protect from alpha and lesser to beta radiation, but it may not protect against other environmental hazards. So if we can't provide shielding through our PPE, we will stay away from it as far as possible, utilizing that distance component and not spending a lot of time close to it, utilizing the time component. We're going to avoid skin contact with radioactive dust. We're going to protect open wounds so it doesn't get, again, inside our body or abrasions from radioactive contamination by covering them. So our bodies or our victims' bodies. And we're not going to eat, drink, chew tobacco, or smoke while exposed. When it is necessary to drink water, we're going to drink from a canteen or other controlled or closed container after we've been decontaminated. Remember that physical injuries are more serious than radioactive contamination. Deal with life-threatening conventional injuries first. So if there is an explosion involved with radioactive material, treat the conventional life-threatening injuries first. Okay? So if there's a major bleed or killer bleeds, we're going to treat them before we worry about the radioactive contamination. And then decontaminate our victims. It's all about what is going to cause the most amount of harm the quickest. Moving on to the I in Be Nice, incendiary devices, any mechanical, electrical, or chemical device used intentionally to initiate combustion and start a fire. Examples would be a bottle with gasoline, a rag, and a match, commonly known as a Molotov cocktail, a low flash point flammable liquid and a candle, match heads and sulfuric acid, or a road flare ignited by a model rocket engine starter. Some indicators of incendiary devices: a warning or threat of an attack. We had that in Alton/Edwardsville a couple of years ago. Disgruntled employee started a fire in his house. He spray painted on his garage door, I believe, that his house had booby traps in it. That was in Alton. And then he went to his place of work in Edwardsville at a warehouse and tried to start little fires in the office building. Everyone was safely evacuated except for him. However, when he would start a fire, the sprinkler system would put it out over and over again. The odor of accelerant, multiple fires, incendiary device components, unexpectedly heavy burning or high temperatures because they've been augmented, unusually fast burning fires, again, they've been augmented by some type of chemical, unusual colored smoke or flames because of that chemical augmentation, and presence of propane or other flammable gas cylinders in unusual locations. Only specially trained personnel should handle incendiary devices discovered prior to ignition. So if you have a suspicion that something is an incendiary device and it has not ignited, isolate and evacuate. If it is suspected that an incendiary device started the fire, proper handling of potential evidence is critical for crime scene preservation. That is part of our responsibility. Moving on to the C in Be Nice, chemical attack. This is the deliberate release of a toxic gas, liquid, or solid that can poison people and the environment. May involve chemical warfare agents or toxic industrial materials. There's just our ordinary industrial hazardous materials that we would see otherwhere. The effects are usually noticed quickly, usually within minutes to hours. However, the results are usually disabling or fatal with a chemical attack. Indicators of a chemical attack: numerous sick or dead animals, including fish or birds, unscheduled spraying or abandoned spray devices, vapor clouds or mist that are unusual for the area, or the absence of crops, wildlife, or insects that are common for the area, time of day, or time of year. Also out of place and unattended packages, boxes, or vehicles, packages that are leaking, materials or equipment that are unusual for the area, small explosions, and unusual odors or tastes. Multiple casualties without obvious signs of trauma, multiple victims who are exhibiting similar symptoms, and large numbers of people seeking medical attention with similar symptoms that are not characteristic of the season. Some chemical agent types include nerve agents, blister agents, also called vesicants, blood agents or cyanide-based agents, choking agents, which attack the pulmonary or which are pulmonary or lung damaging agents, riot control agents, also known as irritants, or toxic industrial materials. These are the normal hazardous materials, however, they're used for terrorist purposes. So nerve agents work by attacking the nervous system by affecting the transmission of impulses. How are they going to get into our body? Through inhalation or absorption through the skin. Symptoms would be increased production of saliva, a runny nose, or feeling pressure of the chest. Pretty much any part of the body that could make a fluid will make it. So these are warfare chemical agents. So they are out there. Fortunately, we don't see them very often. However, they have been used by militaries within the last 10 years, mostly in the Middle East. So it is possible. So there's tabin, which is usually a low volatility, which means it does not produce a lot of vapors. It's a persistent chemical agent that's taken up through the skin contact and inhalation of the substance as a gas or aerosol. So what does that mean? That means it is going to be kind of oily and not give off vapors. It's going to just sit on your skin and get absorbed. There's sarin, which is usually a volatile, non-persistent chemical agent, mainly taken up through inhalation. So it is a liquid that is easily converted to a vapor. Soman, usually a moderately volatile chemical agent, taken up by inhalation or skin contact. So these are all liquids. 6.1 is going to be toxic liquids. Cyclohexylsarin, low volatility persistent chemical. So it's sarin that's been modified a little bit to hang around and stick to your skin, but can be aerosolized. And then V agents, specifically VX, again, a low volatility persistent chemical. It can remain on materials, equipment, and terrain for long periods. Nasty stuff. So that's nerve agents. Blister agents burn and blister the skin or any other part of the body they contact. They are grouped together in mustard agents, arsenical vesicants, and halogenated oximes. Routes of entry are going to be readily absorbed by all parts of the body, so that's going to be absorption. Symptoms are going to be inflammation, blisters, and general destruction of tissues. Blood agents are going to be chemical asphyxiants that interfere with oxygen utilization at the cellular level. They include arsine, hydrogen cyanide, and cyanogen chloride. If you look at those DOT classes, arsine is a class 2.3. Remember, DOT class 2 are gases, so it's going to be in a gas form. And then hydrogen cyanide and cyanogen chloride, hydrogen cyanide is a class 6, so that's going to be a liquid. And cyanogen chloride is a class 2.3. Again, it'll be a gas. Choking agents are chemicals that attack the lungs, causing tissue damage. They include phosgene, class 2, and chlorine, also a class 2. So those would be gases. Irritants, chemical compounds that temporarily make people unable to function by causing immediate irritation to their eyes, mouth, throat, lungs, and skin. Examples would be chlorobenzylidine malonitrile, or CS, also known as tear gas, chloroacetophenone, or MACE, dibenzoxazepine, and chloropicrin, and oleoresin capsicum, pepper spray. With a chemical attack, expect at least a 5-to-1 ratio of unaffected to affected casualties. So you're going to have, for every one person who's seriously affected, you're going to have 5 that are moderately affected. We're going to decontaminate victims as soon as possible. The key there is we need to get this material off of them. We're going to disrobe victims from head to toe to decontaminate successfully. The more clothing that can be removed, the better. We're going to flush with water. Generally, this is the best mass decontamination method. and decontaminate after known exposure to liquid chemical agent as soon as possible to avoid serious effects. They're going to want to get this stuff off you to get this stuff off of them. So lots of water. And remember, when they say a persistent liquid, it means it wants to stay on them. So cleaning them is critical to prevent secondary contamination, them taking it with them. Because they're going to need medical care, and you don't want that stuff getting into the hospital. Have them take their clothes off and hose them down. Mass gross decon. And then the E in Be Nice, explosive attack. There's high explosives. These decompose extremely rapidly, almost instantaneously. These include plastic explosives, nitroglycerin, TNT, blasting caps, and dynamite. And then there's low explosives. These decompose rapidly, but don't produce an explosive effect unless they're confined. They burn rapidly, also called deflagrate. There are primary explosives. They're easily initiated and highly sensitive to heat. There's secondary explosives that are designed to detonate only under specific circumstances. They're less sensitive to heat or flame. And then there's propellants that, again, deflagrate rather than explode, such as black powder. They just burn unless you really confine them. Ammonium nitrate is a common fertilizer that can be mixed with diesel fuel or oil to form an explosive mixture. There's binary explosives, which are composed of two different chemical components, one a solid and one a liquid. There's black powder, a mixture of potassium nitrate or sodium nitrate, along with sulfur and charcoal. There's C4, it's a mixture of RDX and fuel oil. And there's dynamite, straight dynamite, which is nitroglycerin and an absorbent mixture such as sawdust and sodium nitrate. Or ammonia granular dynamite contains ammonium nitrate rather than nitroglycerin. There's emulsion explosives are made by suspending or mixing tiny submicroscopic droplets of an oxidizer in a fuel, such as mineral oil or fuel oil. There's gun cotton, also called nitrocellulose or nitrocotton. It's created by bathing cotton or purified wool cellulose in a mix of sulfuric and nitric acids. HMX, called high melting explosive, is a colorless solid that dissolves slightly in water. And RDX, or Royal Demolition Explosive, is a white powder that is very explosive, is usually mixed with other materials, and is used in detonation cord and blasting caps. PETN is primarily used in booster and bursting charges of small caliber ammunition, in upper charges of small caliber ammunition, or detonators in landmines and shells, and is the explosive core of primacord. Semtex is a highly malleable, which means it can bend, plastic explosive, primarily composed of RDX and PETN. There's also smokeless powder. It's an explosive propellant that was designed to replace black powder. And there's TNT, trinitrotoluene. It's a yellow, odorless solid used in military shells, bombs, grenade, or industrial uses, and in underwater blasting. How are these going to be delivered? Might be in what's called an improvised explosive device, also known as an IED. They are explosive devices that are constructed in an improvised manner, which means they are not commercially manufactured. They are categorized by their container. They're usually homemade for a specific target. They have a firing train that consists of a fusing system, a detonator, and a main charge. Examples are vehicle bombs, pipe bomb, satchel, backpack, knapsack, briefcase, or box bomb, mail, package, or letter bomb, plastic bottle bombs, fireworks, M devices such as M80s, and then CO2 grenades, which they take the empty CO2 cartridges and fill them with explosives, and then tennis ball bombs. So with the plastic bottle bombs, so you can have, there's also ways you can put chemicals or things inside a plastic bottle. Now, they're not considered an explosive, but they do have a rapid, not a BLEVE, a rapid disintegration of the bottle, which somebody might say it exploded in their hand. So be careful of that, plastic bottles just laying around. So if in the event of an explosive attack, some agencies that may be called for extra assistance, if you have a local bomb technician within your agency or nearby agencies, the Illinois Secretary of State Police are the ones that I'm aware of that we call for anything that is explosive related. You can also contact the Bureau of Alcohol, Tobacco, Firearms, and Explosives, or an explosive ordnance detachment from the military. But Illinois Secretary of State Police, I believe, are our go-to agency. Moving on to other criminal activities. So these are not necessarily terrorist activities. These are just other criminal activities that involve hazardous materials. For example, clandestine labs are set up to produce or manufacture illegal or controlled substances such as drugs, chemical warfare agents, explosives, or biological agents. 80 to 90% of clandestine drug labs are set up to produce methamphetamine. We need to be familiar with the products and equipment used in these labs. They're extremely dangerous for us since the chemicals used are often highly flammable, corrosive, toxic, and unfortunately easy to get a hold of. Common products for making methamphetamine include acetone, anhydrous ammonia, ephedrine, ethyl alcohol, denatured alcohol, ethanol or grain alcohol, hydrochloric acid or muriatic acid, hydrogen peroxide, hypophosphorus acid, iodine, isopropyl alcohol, lithium metal, or methyl alcohol. Also, mineral spirits, naphtha, pseudoephedrine, red phosphorus, sodium hydroxide, sulfuric acid, toluene, hydrogen chloride, phosphine gas, hydrogen iodide, and hydriodic acid. Some equipment that you may see with a clandestine lab making methamphetamine would be condenser tubes. So these would be glass tubes that have a tube within a tube. Easy way to describe it. Filters, such as filter papers, funnels or turkey basters, gas containers, glassware, heat sources, such as Bunsen burners or propane torches, grinders for grinding solids into powders, and pH papers and tubing, plastic tubing or glass tubing. All right, some clues from the outside. Windows covered with plastic or tinfoil. I don't know how we would know this. Renters who pay landlords in cash, at least not in hazardous materials emergency response. Unusual security systems or other devices. So I think when they mean unusual security systems, would be either security systems on buildings that you wouldn't expect to have security systems, or not commercial security systems. Excessive trash, increased activity, especially at night, or unusual structures. So any type of maybe temporary looking structure that was put up recently kind of doesn't look like it's supposed to be there or wouldn't normally be there. Discoloration of structures, the pavement and soil, strong odor of solvents, smell of ammonia, starting fluid or ether, iodine, or chemical stained bathroom or kitchen fixtures. So it'll be a brown, reddish brown color or some other chemical stain. So what do you do if you suspect terrorism or other criminal activities? We're going to notify law enforcement. We're also going to notify other emergency responders. And if there's EMS personnel responding, we need everybody who's responding to this incident to know that this is a potential criminal incident. We also need to contact state or federal agencies, health or medical providers as necessary. And we need to get additionally trained and equipped personnel, such as bomb technicians involved. We also need to make sure we're preserving crime scene evidence. Now, that doesn't mean we pick it up and put it in the evidence collection bag. That just means what we do is not going to disturb it to the best of our ability. We're going to take additional measures to isolate exposed people and animals. We're going to take additional measures to secure the scene. We're going to let the least amount of people in. Take additional precautions regarding the possibility of secondary devices. We're going to slow down. If we start seeing some of these red flags, we talked about indicators of criminal activity or terroristic activity, we're going to slow down. We're going to slow down and be careful. We're going to exercise additional caution regarding other potential hazards. Preserving evidence. Number one, unless you must touch something, don't touch. Unless you must touch something, don't touch it. Avoid disturbing areas not directly involved in rescue activities. Don't go wandering around looking for anything other than victims. It's not your job to look for evidence. You are looking for, remember, our three priorities in all incidents are life safety, incident stabilization, environment, and property preservation. So you can look around looking for victims. Once you've cleared an area of victims, don't go back in there. Remember what the scene looked like upon first arrival, as well as details about the progression of the incident. Easier said than done, but try. Also, document your observations as quickly as you can. This is very helpful, as soon as possible. Take photographs and videos of the scene as soon as possible. When you must touch or move something, remember what you did with it. Remember what you touched, where it was initially, and where you moved it to. Best case, photographic before you move it. Also, minimize the number of people working in the area. Leave fatalities and their surroundings undisturbed. Identify witnesses, victims, and the presence of evidence. Preserve potentially transient physical evidence, such as evidence present on victims, or evidence that may be compromised by weather conditions, such as chemical residue, body fluids, or footprints. And then we're going to talk, then how do we deal with the recovery or the termination of the incident? What are we going to do? We're going to return the operational area to a safe condition. So once we have eliminated the life threat, we have stabilized the scene. We either need to, two options. We can turn the scene over to a remediation or cleanup company, or if it's easily cleaned up, then before we leave, then that's fine. We're going to debrief our personnel before they leave the scene. We're going to make sure that they are aware of any signs and symptoms of exposure, even after they've left, even if they don't believe they were exposed. We're going to make sure everybody knows what the chemicals were, if we can find out, and what the signs and symptoms are, and how to contact medical care if they need to, if they experience those signs and symptoms. We're going to return equipment to personnel of all involved agencies, condition they were in before the incident. So if we use some type of equipment, we're going to make sure it's reusable. We're going to decontaminate it and make sure it's ready to go and not a hazard. We're also going to perform an after action analysis, or part of our debrief. We're going to compile information obtained from debriefings and critiques, and we're going to develop recommendations for improvements that can be made once trends have been identified. So if we see something keeps happening, we're going to make recommendations for improvement so we can do better. And that is the end.